Hello, it is sulfur 16 still. Today we are going to learn about the process of diffusion. Diffusion is defined as the movement of fluid molecules from the region of higher concentration to the region of lower concentration. This process is very essential since it enables animals, including you, to perform gaseous exchange. Factors that affect the rate of diffusion. Number 1, temperature. When the temperature increases, it increases the kinetic energy of the diffusing molecules. This results in two random movement of the diffusing molecules, thus increasing the rate of diffusion. On the other hand, decrease in temperature decreases the rate of diffusion. Thus, the rate of diffusion is directly proportional to the temperature. Next, the size of diffusing molecules. The larger the molecule particles, the slower the rate of diffusion, and the smaller the molecule particles, the faster the rate of diffusion. Thus, the rate of diffusion is inversely proportional to the size of the diffusing molecules. Next is surface area to volume ratio. The larger the surface area to volume ratio, the higher the rate of diffusion, and the smaller the surface area to volume ratio, the lower the rate of diffusion. This implies that the rate of diffusion is directly proportional to the surface area to volume ratio. Next, the size of membrane. When the size of membrane in which the particles are diffusing is large and thick, the rate of diffusion is slow compared to the membrane which is small and thin. This implies that the rate of diffusion is inversely proportional to the size of membrane. Next is the concentration gradient. The higher the concentration gradient, the faster the rate of diffusion, and the lower the concentration gradient, the slower the rate of diffusion. This implies that the rate of diffusion is directly proportional to the concentration gradient. Next is the density of the diffusing particles. The rate of diffusion increases with decrease in density of the diffusing particles and decreases with increase in density of the diffusing particles. Therefore, this implies that the rate of diffusion is inversely proportional to the density of the diffusing particles. Let us talk about Graham's law of diffusion. The law states that the rate of diffusion of a gas at standard temperature and pressure is inversely proportional to the square root of its density or molar mass.